In this video, we'll look at regression analysis with two predictors. So again, yeah, we use this data set. So we'll still use salary as the outcome, but we'll not only look at education, but also looking at the years of working experience. And we'll see how them together they predict the salary. So before we run the multiple regression, we can look at the scatter plots, looking at how these variables related together. So you go to graph and legacy dialogues, and you go to scatter. So we're going to use this matrix scatter because we have three variables here. So I'm going to put all these variables in the matrix variable box, and then OK. So this is the matrix scatter plot. And what I'm interested in, so the bottom two scatter plots, because this salary is at the y-axis, and with working and education variables on the x-axis. So this is the one we looked at before. That's the scatter plot between education and salary. And this scatter plot is between working and salary. And you can see that they also there's seem to be a linear relationship. It seems to be positive, and this is potential might be a variable that's a little bit different from others because we have a small data set. Yeah, and the we can also look at how education is related to working. Yeah, so this is the one, and you see that. They seem to be related also in the positive trend, but it's not seems not as much related as working and education with the salary. So once we have checked the scatter plot, we have each of these predictors seem to have linear relationship with salary. Now we're going to run the regression. So we go to analyze, regression, linear, and we just add the working variable into the independent box. And I think let's check statistics. So this is good. Again, in the save button, we can have this still checked to get the predicted value and also the residuals. Then continue, and the options. Okay, yeah, so then we just check OK. Now we have this regression output. You see that this is the descriptive statistic table, and we have the working variable added. So the average years of working is 15.3 years, and that's the standard deviation. So this is the correlation between these three variables. And so for salary, education correlation is 0.8 to 6. And working also positively related to salary, the correlation is 0.695. And so the correlation between working and education is 0.31, which is smaller than the predictor with the salary, just like we have looked at the scatter plot. So then the next is we're going to look at the model summary here. So this is the model summary table that shows the multiple R. So basically, multiple R tells that how these two predictors together correlate with salary. You can see that together, this is 0.946, which is increased than if we look at the education alone. And so the combined, the two predictors combined explains 89.6% variation in salary. And then you see that standard error, the residuals, the average, the error, that's around the regression line. And so here, this is regression plane. is further reduced. So because the two predicts together explain more variation in salary. In the ANOVA table, so once this is a test for the regression model, like I mentioned before. And so this is now we are testing the two predictors. So both together, both predictors together explain a significantly amount of variation. So the p-value is significant. It's actually even more significant than we had before with one predictor. And this is the regression coefficients table. So we have the regression intercept, and we also have this regression slope for each of the variables. So now we can write a new regression equation. So this will look like, again, yeah, we use y prime, and here the what happened? So equals the intercept, which is the average salary, including the two variables. Yeah, so the regression slope for education is 495. Because maybe type x1, that's the education variable. And next slope is 0.210 times 2. That's the working variable. So this is our new regression equation with the two predictors in the equation. And so they tell us that if so the slope tells us that we do see that the regression slope with education is changed, it's actually reduced because we have the other predictor in the model. So this tells us that if we control the years of working experience, education with one additional years of education will bring will increase the salary by $495. So it means that for people who have same years of experience, one additional year of education will increase the salary on average by $495. And so if we look at the regression slope for working experience, then it tells us that if we hold education constant, one additional years of education will increase the salary on average by $210. So that's how we interpret the slope. If we look at the slope, the test of the slope here, the t-test, so both come out significant. And the same thing here, if you look at the confidence intervals, so now for these confidence intervals include 0, meaning that the regression slope is not equal to 0. That also means each of the predictors significantly predict the outcome. So that's the regression, linear regression output. So if we go back to the data view, we find that since we use check the save button and check for the unstandardized predicted value and the residuals, that's what we get. So with the two predictors in the model, and that's how we what is the predicted salary, and that's what is the prediction error. So if you compare this with the one we had before, the prediction error should have reduced than was before. So this tutorial is to look at regression analysis with two predictors. Thank you for watching it.